Okay, so we're going to look at this diagram, and we're going to look at some rules that we knew existed when we were doing that electron shell model, and we're going to see how it fits into this new model, which is more consistent with the quantum mechanical model, okay? What I want you to notice with this diagram, first of all, this is called an orbital energy diagram. Orbital energy diagram. Because what you can see is what's happening on this axis is energy is increasing, right? And you can see that these numbers are increasing as well. The numbers 1, 2, 3, 4, and 5 are saying the energy level number, all right? Then you should recognize these letters, S, P, and D, because those coming from your quantum mechanical model foldable was when we were talking about the subshell. So again, the shapes of the clouds of electrons that are going to form. Now, if again you want to look back to this quantum mechanical model, you should remember that the S subshell or circular shape only contains one orbital, right? The P shape, remember that was the dumbbells where it was up and down, side to side, front to back. That was 3 different shapes that they could be in, or 3 orbitals, okay? Do you guys remember how many electrons can be held in one orbital? 2, right? So theoretically on this diagram, each one of these little dashes can hold 2 electrons. So essentially, for all the different atoms, we're just going to fill in where the electrons are going, not only in terms of energy level, which you can see relates to distance from the nucleus, but also subshell, which you should remember refers to the different shapes, and then how many electrons are in each of the orbitals that make up those shapes. That's what we're looking to do today. Okay, so you have to follow these rules, and the first rule is the Aufbau principle, which is we're going to fill the lowest energy level first. Okay, so that just means basically we're going to start at the bottom and we're going to build our way up. I can't just start jumping around, spreading out electrons wherever I want. They have to be full before I can go to the next one. All right, another important thing, especially when we have more than one orbital, is that Hund's rule, where electrons want to be single before double. So that means that I'm going to put an electron in each one of these different orbitals before I start doubling them up. It would be like if you had 3 rooms in your house and 3 people live there, you wouldn't like share a room and leave one empty. You'd probably each have your own room, and then as more people started living in your house, you'd start sharing rooms, right? That's the same concept. And then the very last thing that we're going to take into consideration is that no 2 electrons occupy the same space at the same time. Okay, and again, I'm going to refer back to that quantum mechanical model foldable that we had. That is where spin comes in, because we're going to have different spins to our electrons to make sure that they're not going to jam each other up. All right, so what we're going to do to start putting electrons into all of these little orbitals is we're going to make a mark that's going to represent an electron. We're not just going to say like 1. We're going to indicate that one of the electrons is going like clockwise and one of them is going counterclockwise with an up and a down arrow. Now, drawing arrows is going to take too much time because there's 2 marks that you have to do. The way that chemists are going to shorthand that is they're going to say this right there is an up arrow. I know it kind of looks like half of an arrow, but that's how they do it. And then this right here is a down arrow. Okay? Good so far? Cool. Let me show you how you guys are going to use this. Make sure you guys are watching. What I suggest you do is don't copy what I do. Just watch me do it and then copy it. Okay? Because I'm going to do magnesium. And my first step is going to be how many electrons am I putting in here? So you would look at your periodic table, you'd find magnesium, and you'd see that it is atomic number 12, right? So that's 12 electrons as well. So I am going to start from the lowest energy level. I'm going to make it single before I double up, and then I'm going to also do an up arrow and a down arrow in each one of the orbitals, okay? So I'm going to start with electron 1, electron 2, that's full. Go up to level 2, electron 3, electron 4, that's full. So I move up over here. Now watch again what I'm doing here. I'm going to do electron 5, electron 6, electron 7. Why did I do that? Why did I put the electrons onto 3 different lines?
Because they don't want to be double.
Yes, they want to be single before double. So if I only had 7 electrons, that's how they would orient themselves. But I have more than that. I have 12. So I need to keep adding them. Now I can double. So I'm going to say 8, 9, 10. This is full. I have to keep going. 11, 12. What questions can I answer about what I'm doing right now? Nor? Do you just have a question? You don't believe it? I promise you, I'm not lying. I didn't make this up last night. Like, oh, what am I going to teach them tomorrow? Okay. So, because I know this is new, I do want you working in your groups. You don't have to, like, thinking, pair, share it. But with that second blank one that you have, I want you to try this out on your own for sulfur. Okay, so I'm going to go to the left side here, because eventually you're going to put this here, but work with it not glued in already. If you do, it's not a big deal. But it's just hard to like write on a glue paper, I think. So do sulfur. Here's what you're going to do in your groups. You are going to, and you can designate this to each person if you'd like to, but you're going to count how many electrons sulfur has first. Second, you guys are going to start talking about where do they go. You're going to put it on here, starting with the lowest energy level first, filling it up before you move to the next one, and making it single before you start making it double. Okay? Then you're going to do the electron configuration. I'm going to help you guys out with that in a second. So for right now, just do how many electrons and where do they go. Okay?